And we're live. So it's the weekend, and that means doing something, well, not something completely different, but IMVU related, but not related to what's been going on during the week with teaching Shannon Mack how to make love in Blender. There, I said it. We've got this turkey to finish. So what we're going to do first with this is prep it for use as a furniture item, just as a standard basic furniture item, and then depending on how that goes, we can then do some more fancy stuff to it. So what we could do first is just convert it into a furniture item that doesn't do anything, doesn't have any seating. So no seating. Just making a note of this. And then what we can do is add a default seat. And then if, depending on how it goes, we can then maybe perhaps do a custom. Either a custom seat, or what might be more interesting is to make this an animated furniture item, which will mean setting this up so that it will move as a furniture item. And we can do that a couple of ways, but I'm going to try something that should work now that we have FBX Export and Import. Now that we have that available, we can create animated objects using a much more simple setup rig. We don't have to use skeletons and armatures anymore. So first things first, then let's get this thing prepped for use in IMVU. Use in IMVU. So it's all separate components at the moment, and for this to be usable as a furniture item, ideally we need to join everything together. And we've also got a series of materials, so each object has its own material, so those change depending on what's selected. Now there are a couple of ways to do this, depending on what you're actually wanting to do. So, and if it's a furniture item that doesn't do anything, then you can do it one way. But if it's a furniture item that needs to animate, you have to kind of do it another way. So the first way would be to join all the objects together based on their material assignments. So what we're essentially doing is creating a group of objects for final export that are all defined based on their materials. So we could join all the rivets together, and that would be one object or one mesh objects. We could join the body and the head together because they use the same texture, and that would be another object. And then the wings would be separate, the tail would be separate, and the beak. So the beak, the eyes, and the feet. But during export to FBX, all of those will come in as sub-meshes. So you'll be able to export one object, as in one project, but the project on import will be comprised of different mesh elements. And this, it's not so much an advantage, but what this does facilitate is that it makes texture assignment clean, because each mesh has its own texture assignment. So you're not going to encounter problems, or you're not likely to encounter problems where you've got, say, the beak texture or material attributed to the tail texture, and vice versa, because that can sometimes happen when you import a number of objects at the same time and a number of materials. Whoops. So what we'll do with this is, what we need to do is, I think probably the easiest way is just to join everything together into a single object, and we'll use the feet. So we'll shift right click the feet last. Those become the active element in the selection, and it also means that it's using the origin point of this particular object. Oh, we'll need to address that actually. So we'll join them together. So that's either from the object menu, join, or just use Control J and it'll join everything together. And that'll give us a series of materials. Now for this to work within IMVU, we have to do a couple of things for prep before we do anything else. First is just renaming, well, it's not renaming as such, it's amending the material names so that we have the numerical appends that IMVU is looking for. Whoops. So you just click on the material to select, and then, or you can actually just double click the material entry in the preview. Use your keyboard and go down the list, and it doesn't matter the order or the number. So if you had assigned these in a specific order, for Blender users, there's no point in paying too much attention to that, because the materials and the texture assignments tend to be jiggled about when they're exported, because if I remember correctly, they are interpreted based on when they are created, not necessarily when they're assigned. So you could, let's say for the sake of argument, so we've got 0 at the top there, and 1, the next material down, could be this one at the bottom, in terms of how you created them. And it would ignore, so on export 1 wouldn't be up here, it would still be down here, and it would show like that in IMVU as well in create mode. So what number 2? Number 3. Double click. Number 4. Double click. And this is needed so that IMVU knows the material slots that are supposed to be available, because it's not using the actual name, it's using the numerical append. So that's 8 materials. Yes, so as Frenzy is saying in chat, when you're having an issue with the materials, you can double check your assignments by, once you've joined the mesh, this is in Blender, once you've joined the mesh and you're in edit mode, make sure you're in, well, it's generally best to be just in face select, and then you can use your material assignments to double check your material assignments on the object. And those should, once they're exported, those should correspond with what you see in IMVU. Right, so we've joined everything together. It's a single object. Single object, and so we now need to do two things. We need to don't necessarily specifically need to do this for FBX, because FBX uses the scene position or scene coordinates. So if this object were back here away from grid center, FBX would use this position relative to the scene for the position of the object in the FBX file when it's exported. So unlike with Cal3D, where we used to have to make sure that the origin point, which is this little dot where the widget is, that for Cal3D that always had to be, you always had to make sure that that was located grid center or center of the object, and then you locate the object grid center. So we've got the cursor there, so double check 0, 0, whoops, 0. So that's now smack in the center of the grid. And then from the tool shelf, we want origin to 3D cursor. And the widget moves, indicating that that's now been reset. Lots of hugs going around in chat. So once that's done, next thing to do is to fix the size of the object. So we've got dimensions and we've got scale. You can see those in object properties as well. So we've got location, rotation and scale. We need to change scale and reset the mesh so that that doesn't read decimal points. And for that it's either Control A or Object and Apply. And we want rotation and scale. And that's reset the mesh so that it is actual size, real size. Again, if you're using FBX, you don't specifically need to do this, because FBX will interpret the object size as is within the scene and export it properly. If you're using Cal3D, you'd have to do this. So once we've got that, we can save the file or save a version. Save as 15. Save. So that's the basic object. So what we need to do next is open up the furniture file, or the furniture starter file. If I can find it again. There we go, furniture nodes. Oh, in fact, actually, what we could do, this is optional again. So if you've got a load of objects in the scene, this is one of the reasons why you generally want to try and unify the object and join everything together. So if you've got a lot of objects in the scene, one of the things that you'll probably want to do is just rename the object so that you know which one you need for the next step. And you can rename the object and its object data. You don't necessarily need to do this latter one. So once you've got that, save the file again. Whoops. Save the file. So what this does, if you've got loads of objects in the scene, in the next step, renaming the object name or giving it a name that you can easily discern helps with the selection. So the next step is to load in the furniture sample file, starter file, and then we need to append the Turkey mesh. So from the file menu, append, and we need to browse to the Turkey file, robot Turkey number 15. So just left click that once. When you append the files, the Blender project files, they act as zip archives or archive files. So when you click on them, you would essentially go inside the file like you would do with a zip file or an archive, and you have a series of folders, and each of these contains a specific type of data. When you're appending or doing simple appends, you just want to click on the object folder, and that'll show all the objects that you were just working with, and we should have, and there it is, that's the one that we want, Turkey mesh or turkey.mesh. So that's why you would rename the object so that you can tell. I mean, we've got spheres 11 through to 19 and all sorts of number of cubes and cylinders, and none of these names are particularly helpful in terms of determining what it is that we're trying to bring in. So select that, left click, and then we can append it. And using the default scene scale, it'll be tiny. It is there, but it's tiny. So what we'll next need to do is scale it up. So press the S key, S for Simon, and just move the mouse and scale the object up. And for this, we want it to be about the height of the default cube, which is this green thing. So S, scale up. Whoops, it's a bit big. If you find that when you are doing scaling or rotating or moving an object, if the mouse is being, or if the activity is responding in a way that means it's essentially oversensitive, press and hold the shift key down, and that'll slow the action down. So we want it about the height of the cube, and then left click to set in place. Yes, there's not much I can do about the commercials, unfortunately. I guess that's how Twitch is funding itself, I guess. I mean, unlike YouTube, Twitch streamers, as far as I'm aware, don't see any of that revenue. So the appearance of those things is nothing that I can particularly do a thing about at the moment. Oh, you don't have commercials if you're Prime. Okay, that's good to know. Right, so what we've done is appended the mesh into the scene, and it's come in super tiny because of the size differential between Blender's default and IMVU's default. IMVU is about 100 times larger than Blender's default, so you will always have to scale if you start your project from the default Blender scene. So what we can do now is, as for a simple furniture item that's not going to do anything, what we want to do is just hide this green cube so that we can see the turkey. So right click select and press H or object, show hide, and then hide selected, and this just hides it as you would do with other programs that have a similar feature. It's just hiding it, it's not deleting it. So that's our turkey. and it's positioned relative to where we need it to be, because we sorted that out in the other file in a previous video. So its feet are on the ground. It's not quite positioned center of the grid, but that's okay. We need to reassign or double check smoothing assignments on this, because we've got some faceted, these are supposed to be rivets and they're supposed to be smooth, but they're not. They've come in faceted, so there's no modifier here. So we are probably, yes we are, using auto smooth. So smoothing, that's these two buttons here. If we do flat shading and then smooth, some of these change but others don't, and that's because the angle that determines whether the lighting from the scene or the illumination or the shading across surfaces is smooth or faceted. The simple method of doing that is using the angle here. So if we increase that, we should see these smooth. So let's try 60. Yeah, that's okay. And this is one for Liana. These aren't warts, they are hinges for the beak. So once we've got that, we next need to reapply because we've changed the scale of the object. So object menu, apply, rotation and scale, or just use Control A, and that'll bring the pop up. So what that's done is reset the object. So if I just undo that, we can see that the scale of the object has been changed significantly relative to its default. So we need to fix that and reset the mesh so that it's all 1111, which basically means its actual size. Again, if you're using FBX, you don't specifically need to do this, but you do if you're using Cal 3D. And I know quite a few people still use that. So that's our mesh imported or appended into the default furniture item scene, which we can now do a simple furniture item by right-click, select the mesh, right-click the root node, which is this wireframe, and then either Control P, which is parent, or object menu, parent, object, and in the pop-up, object keep transform. And you can double check this. If you right click the root node, press the G key and move the object, it'll move, the two of them will move together. So that tells us that we've got the mesh parented to the root node. That's the word I was looking for. So save the file. Always save your file. Be mindful that you don't click save, because you'll save over the template or starter file. So save as. And this is Robot Turkey 16. Save. Yes, I mean that's one of the reasons why IMVU, Leon is just saying that FBX is going to be better for Blender users particularly. That's one of the reasons why IMVU brought the FBX system into play, is because they wanted to get people back involved in creating original mesh content because they've been aware of the problems or the limitations with Cal3D for some time. So that's one of the reasons why they implemented the FBX stuff, to make it easier. So once we've got our two objects, and this is just a very basic furniture item, so this is the most simple form of furniture that you can make. So right click the mesh, right click the root node, and then export. So file menu, export, FBX. And then in the file browser that appears, browse to the location you want the project to be saved. So that's you're going back up. It uses the same analogy or the same process or system as Windows. So you can just click on the folders and access the contents of the directories. So bottom left, we have all the FBX stuff. If you've got a lot of objects in the scene and you're exporting specific objects, make sure selected objects is active. So left click that checkbox. Leave scale as is. Geometries, you can the guys at IMVU prefer you to have apply modifiers active, but preference should be to apply your modifiers before you export, rather than relying on the exporter to do this for you. It avoids having issues. Then armatures. Then in armatures, make sure add leaf bones is deselected, or disable that. Animations, that can be left as is because it's not doing anything at the moment. So once you've got all of those set, so that's selected objects, apply modifiers and disable this one. Armatures, disable all of that and leave animations untouched, and then just export. And that'll export those two objects and produce an FBX file. Next step is IMVU. So create slow. Derive a new product, and we want a standard furniture item, which is the default chair. Click go. That'll open an editor and the chair will appear in there eventually when the computer decides to do that. So that's our default that we start off the derivation from. So FBX Import. FBX Import tab, click that, then load FBX, the button. That'll open the file browser where you can browse to, as normal, the folder location that you save the project to. So we've now got to find Turkey, Robot Turkey 16. So select, open. And as this is a simple object, a simple furniture item, it bypasses the need for skeleton selection. So if you're importing different types of objects, say an accessory or a pose, you'll get an extra dialog box where you set up or select the skeleton that you want the imported data to be associated with. With furniture items, we generally don't need that, and it'll just drop the imported mesh data into the importer. So, as mentioned in earlier, the order in which the materials appear is completely, well, it's arbitrary relative to how they're set up in Blender, and it does that, I think, based on the date or time that the materials were originally created. So wings might have been the first material, tail the second, body rivets the next, and so on. So we've got all the materials, we've got the mesh, and we need to renumber that to 0 so that it overrides the default seat. And then once we've done that, we need to change the scale to match what we're looking at right now. So for Blender, if we use the defaults on export, so we're using the 1.0 that was being displayed in the scale property value, property box, we need to do 0.01 for this. Leave your axes alone and then just import. And hopefully this should bring in the, we'll get the import status box, and this is telling us that the default chair materials are being overridden by some of the materials that we're importing, which is good, you want that. So then left click, import changes, and it does its thing, and of course as per normal you have to click apply changes, and there is our turkey. And using FBX, it dispenses with the whole bringing in a blank mesh that appears white, and then you have to go through the rigmarole of assigning all the materials and the textures. So it automatically assembles everything based on what it sees within within the file. So what we can do well, Frenzy, if the object is not importing the way that you're expecting it to, then there's probably an issue somewhere with the material assignments, because it should do what it's just done, what we've just seen. If the object is set up correctly in Blender and you export it as a unified object with all your materials assigned, and each material has an actual image bitmap, then it should just automatically reassemble it on import. So double check your material assignments, and or that you're using actual bitmap images UV mapped or assigned to the UV map that whatever your object is. If you're using the generated images, which are so this info, if you fill in this info and click OK, you are creating a temporary generated image, and if you export, the materials will come in. Well, they won't do what you're expecting them to do. So make sure that you have actual bitmap images assigned to your object's UV maps. Oh, bitmap. Bitmap is the term raster. It's the bitmap is a format, obviously, but it's also just a generic name for an image, an actual, well, physical image. So it can be PNG, TGA, or JPEG. In fact, has it... So that's just checking the image format that was used for the Turkey. Oh, that's interesting. Okay, so if you use... I'll have to double check this with Code Rodent, who's the FBX well, he was one of the engineers on the FBX team. But these were TGA images, which you want to try and use, but I guess on import it's converting them to JPEGs. So as long as you use a format that the FBX importer can interpret, it will convert them into a suitable format. Okay, so we put in a IMVU derivable product and then bring in our FBX. Yes, DJ. Yes, so yeah, so you are deriving, because this is just the same as deriving a product normally. So what you're doing is creating a derivable project and then replacing the defaults of whatever that project is, whether it's a chair item or, you know, a room item. You're replacing all that stuff with your own when you import it as an FBX. And assuming you've got everything set up, it'll just override everything when you import. So yes, TGA is another image format that we can use rather than, or instead of, or as well as PNG or JPEG. It'll convert it, or it should convert it when it brings it in. But what we also can do is, so let me just double check. So that's on the feet, so that should, I may have to quiz Code Rodent again, the FBX engine. Oh no, it is doing it. Excellent. So what we've also got access to is vertex colors or vertex painting, which we did. So if I in fact, actually, it'd be easier just to show it in here. So this body and the head, they use the same texture. It's just one texture, but it's darker on some sides than it is on the on others. Not because of the lighting of the scene, but because we use vertex colors. This is the rivets, and you can see that they shade. And we can go around the entire mesh and enable vertex shading or vertex colors so that they can be seen. And this is a cheap, quick way, as was explained in the previous video, which I'll link to once this thing's archived. It's a cheap, quick way of adding shading to the object. There we go. It's easier to see on the body and the torso, the body and the head. So that shading means that we can use one texture, and it is literally just a... let me just open it up. Slow computer. Debs, you don't specifically need an empty derivable, because it doesn't really, if you're going to replace the entire contents of the default object that you're deriving from, then whether you derive from an empty derivable or, let's say, the furniture chair derivable, the default, it won't matter, because the empty derivable that IMVU provide us it's a derivation of that furniture item, but they've just cleaned out all the stuff. So in the derivation tree, you've still got that chair. It's just that you don't see it when you derive from the empty derivable. So it doesn't really matter if you are replacing everything. You might as well just derive from the defaults that are available. So these are our textures. Windows tile. So there we go. Those are our. So they're pretty simple, and we're using one image for the entire body and head of the turkey, which we can then cheat a little bit with by using vertex colors to make it appear as if we've got a more complex texture assignment on the object. And that's what vertex coloring or vertex painting will allow us to do. So select your mesh, vertex painting, and you'll get this pop-up. We've gone over the. I'll link to the video where we did this in depth. Once this is archived, I'll put it in the description so that you can watch that. But essentially, you can then paint over the mesh and shade it. And that just gives you a cheap way of shading the mesh. So undo that. And that's the turkey object as just a static furniture item. So let's just save this so that we have a copy of this. FBX turkey static. So right, so let me just read the chat, see what questions there are, if there are any. So if there are any questions, all good so far. File size, if you want to check your project size, you will get that information from, let me just double check. Yeah, you'll get that information more accurately when you upload. You can check it to some degree in the assets tab, but that's giving you the raw numbers. That's not what IMVU sees per se. This is the raw numbers as we are seeing them in the editor. So you won't get the actual compressed project file you won't get the data for that until you export. And then of course you've got the debug, which lists all the elements, but that's more to do with the structure of the file rather than necessarily its file size. So that's the object that it's been derived from, what it contains. So it's listing all the texture maps and the meshes, all the materials, and so on. But this allows you to make some changes to the mesh should you need to. And assets, obviously, if you replace these textures, you might find some entries showing up here highlighted in an orange or salmon color, which basically means they're not being used, and you can select them and delete them, and that'll clean the project up. A filing class frenzy? What's that? Yes, you do, Hot Rod, yes, you do need to watch your assets before you bring them in. Obviously you've got to try and keep your file sizes as small as you can, so the final project size isn't obviously too big. What's the limit? 2 megabytes? Is it 2 megabytes per derivation? Oh, right. Friends is just saying that it's a project that she's working on. So that's a very basic furniture item using the Turkey. So we can now move this around as a object. It's a standard furniture item. In fact, it'll even go up on the walls and the ceiling if the nodes are still up there. Yes, they are. So there we go. Turkey on the ceiling. So, so Deb's asking, so how do you get the megabytes down compressing the file sizes? Because a lot of meshers are able to get huge projects. Well, that's so basically that's a question about file sizes. Most of the assets, well, it's a shame I can't zoom in on this area, but as you can see from this assets assessment, textures take up a huge amount of space relative to other elements of the project. I mean, the mesh itself, that's quite large, obviously. But most of the file size of derivable, most of the file size that's taken up, that's consumed in the end product, is going to be textures. Yes, cold turkey is going to be taken up by turkey, going to be taken up by textures. Now, depending on the complexity of your texture, that will determine how large the file size is. So this is essentially, let's do this one. This is essentially 1, 2, 3, 4, let's say half a dozen. So this single image is comprised of 6 different tones or colors. That basically means that when the file is saved, it's only saving 6 color values, and obviously it's using those depending on the color, either a little bit or a lot. But because it's only using 6 colors, it means that this file can be compressed hugely when it's finally imported into IMVU. So although we've got the raw data here, which relates to the physical dimensions of the object or the texture, that relates to this being a 256 by 256. So what that number relates to is the pixel dimensions. So 256 by 256 equates to however many pixels that is in data, not in image. So ignore what you're seeing. It's just the physical dimensions of the image. So when that's imported into IMVU, IMVU is just reading the raw image data. It's when it's exported and uploaded that it compresses the file. And a texture like this will compress quite nicely because it's only a few colors within a palette, whereas this might not because it's using a few more. Or I don't have one. Yes, I don't have one within this project, so let me see if I can find one. Yeah, so whereas this is a texture that Jinx did for the pumpkin contest. This, if these two textures were the same size, this top one would compress a lot better than this bottom one, because this bottom one has a lot of, well, it's got more tonal variation, and it's that tonal variation that increases the image size. So that's where most of your stuff to do with how big the project is, and in the final upload, that's where it's all coming from. It's the textures rather than the mesh. How do you minimize? Oh, vertices. Well, that's going to be mesh density. Vertigo method medicine. Yeah, no, it's that's going to be how well you construct the mesh. So if we take a look at our turkey in wireframe mode and switch, we can see that it's not, hang on, let me just switch to, this will make this slightly easier to see. I'm just switching the theme over to a lighter color so that we can see the, I think it's that one. Yeah, there we go. Oh no, that's not the right one. There was a default. Oh well, we'll use this one for now. Oh no, that's right. Your vertices and how heavy in terms of file size the mesh is going to be determined by how complex or how dense your object is. So we've got an object now that is 1,100, well, it's just over 1,000 vertices, which is this section at the top. That gives us some basic information. But what you'll find is that people will do this. And that increases your vertex count hugely without actually adding any, it doesn't add anything to the project in this particular instance. So that's the one thing that you have to watch out for, is your optimization in terms of the physical structure of your object. keep simple objects simple and save your increased density for curves. So if you look at obviously the side of this box, it's just one face, but the wings have much more more faces are needed to describe that curve. Yeah, so as Leanne is saying, the more complex or more organic a model, the more vertices and polys you'll need to use in order to describe the shape that you are working on. And that's where most of your... So for instance, if you did a vehicle, whilst you might be able to describe the main body of the car with, let's say for the sake of argument, 200 polygons, in order to get the wheels to look round, you might have to use 200 polygons per wheel to get the shape right. I mean, I wouldn't advise you doing that because that's actually quite a lot, but that's the analogy. So, and that's where most of your mesh file size will come from, is when you don't pay too much attention to the distribution of your vertices, how many you've used, mesh density basically. Yeah, well, yeah, so square wheels are where it's at. Right, so let's reload this file. 16, reload. Because what we can do now, so we've got our very basic furniture item. Whoops. Very basic furniture item. So what we can do now is, let's try animating this. Now this could be tricky depending on how we want this to behave. So let me think. So we need... Yeah, as Liana's pointing out, that's probably one of the reasons why a lot of meshes that come in to IMVU are very dense, because they come from DAZ 3D or DAZ Studio or something of that nature, without any particular attention paid to optimizing them. So that's something that, I mean, if you're making the meshes yourself, you won't have to contend with this. It won't be an issue, basically. It won't be too much of an issue. It's only a problem when you're using subdivisions and increasing the mesh density without actually increasing the detail. And that's one of the problems that generally happens when you use subdivision, is that it's not, you don't just use subdivision just for the sake of using it. It's used for a specific purpose, and if adding it doesn't add anything in terms of to the detail of the object, then there's no point in using it. So for IMVU you generally don't need to use it. So let's reload this file. Right, so what we're going to do is create a very basic animation. So yes, that's Hot Rod. Yeah, that's what people do. They use DAZ 3D or models of that ilk and try and bring them into IMVU, and of course it cripples the system. Right, so we want to animate this. So when you're animating furniture items, the best way to do this is to leave the root node. This is the node that IMVU uses to locate the furniture item in the scene. So don't do anything to this. This always has to be at the center of the grid in Blender, that is. So what we want to do is add where is it? There it is, empty. We want empties and a cube. So where's my cube gone? Oh, it's the same size. So we can change the size of that. We can either press the S key and scale it down. Oh no, is it? Oh no, it's tiny. It was the other way. So what we can do is left click the scale value input box in object properties or data properties, and we can type a value. So let's type 50, and that'll bring us up. It'll increase the size of the node. Yeah, we can't with this particular type of animation we won't be able to do anything particularly complicated. So what we're doing is we're setting up a proxy. So this node that we've just added to the scene, that becomes the root node of the turkey. So we don't move the root node of the furniture item, we move the proxy root node for the turkey, which the turkey will then be linked to, and then this one, the turkey root node, will be parented to the root node. So it'll all make sense in a little bit. Right, so we want to turkey root, we need to call that turkey root. So in object properties, left click the name field, so turkey root, IM root, and then we want another node, add empty cube, and that's super tiny as well, because again it's using Blender's default. That's 1 unit big, that cube, or 1 unit small. Go back into object data, left click and type 50 again. What we want to do with this one, I don't know if you can see that because of the grid, we want to move this using the origin point, which is that little dot. We want to position that just at the top of the legs, because what we're going to do is use this as a pivot. Right, so now to get this to work, we need to use something called vertex groups. So right click your turkey, or right click the turkey or the mesh, enter edit mode, and the quickest way to do this is just to select the entire object. Oh, what we haven't done actually is this new node, rename that torso. So we need to create 2 vertex groups. So we're in edit mode, object data, and we want the vertex group section. Just click the plus button twice, doesn't matter at the moment, So we want two groups. We want one to be feet and the other to be torso. And at the moment we've got everything selected, so what we can do here is just select, left click the torso group and assign it to everything. And we can check this using the select and deselect buttons. And then what we next need to do is select the feet, so we're switching into side using the numpad keyboard to switch back and forth between the views. So deselect, and then using box or border select, that's the B key, B for Bert, want to select the feet. As we're in wireframe mode, that will select both sides. Then select the feet group and assign that. And we can double check by doing that. But we will also still have the assignment of torso to these, like that. So what we need to do here is deselect, use the selection that we've just done. So we select the feet, select it, which selects it in the 3D view, and then what we can do is left click the torso group, which is still active, and then remove them from the selection. And this will mean that they'll now not work. So if we deselect all of that, A key, clear the selection, and then select the torso, it'll select just the torso now. So that's a quick way, or a more straightforward way, of reassigning your vertex groups and cleaning them up. So you can create a number of them, assign one to everything, and then make your selections, assign the others, and then once you've done that, you can use those other secondary selections to clear your primary selection. So with that done, what we need to do, now I don't know if this will work because of the way that FBX works. So what we may need to do for this is in fact, actually, I wonder if this will work, because no, Frenzy, not you can't really do that kind of complex animation with this particular sort of rig. Essentially, let me see how. Okay, I think what we'd have to do with this, if we use nodes, what we might have to do is split the mesh up. Hang on, let me just double check this. I'll just save this. Save as 17. Because no bones, no. No hot rod. Not for simple stuff, but simple stuff is usually, let me open a previous project. Because this may not work, because when you need to have a hierarchy of more than one control element, it starts to get tricky, because what you should do, the body is parented to the feet. Keep transform. So that means when the feet move, the body moves with that selection, and then the feet are parented to the root node, furniture node. So when the furniture moves, everything moves. But that's just moving those particular elements. The tricky bit is how you then make the association between multiple levels, or the hierarchy of the... So we've got two vertex groups assigned to this object. The master vertex group is actually the feet, and the feet are controlled by the feet node. But these nodes are completely separate objects. So if we were doing a simple animation where... Whoops. So let me just clear that. So that's... Keep transform. Oh, no, that's Alt P. Keep transform. Right, so if we parent the mesh to the feet, this is what this would generally do. So you've got the root node controls everything. The feet would then control the turkey. But then the issue is what? How do you use the third node in the hierarchy to control the turkey's body? Because the turkey is parented, the entire object is parented to the feet in order for that to be moved. Now, if this were an armature, there'd be a relatively straightforward way to get around that, because of obviously the way that armatures work. But when you use nodes, you have to think about it in a slightly different way, which might complicate things. Although nodes are easier to use for certain things, it overcomplicates it for other things. So for instance, if I poses, so I've saved that file, where's the pose? Oh, it's that furniture item. Hold on, I'm looking for a... Right, so here we go. This is a super confusing file. So if I just play the animation, we can see that these spots move. And they all move relative to a control node, which are these. So they work because each of these is an independent... Each of these is an independent element within an overall furniture item. But in order for these to control specific mesh objects, the mesh objects have to be completely separate objects. So for something like this, that's okay, because when this is imported into IMVU, what you end up with are several independent mesh objects which all attach to the same skeleton. But in order for these to be controlled by specific nodes within this setup, each of the meshes has to be separate. So in relation to the turkey, and doing more complicated animations, to use nodes, you have to split the turkey up. So you'd have to split the legs away from the torso. And that would work to an extent, depending on the simplicity of the animation. So I have to think about this in terms of what's the best way to do this. Because what can happen, in fact, actually, it may be a better option to use a skeleton for this, an armature. Because what can happen is, well, let's say for the sake of argument, the turkey moves, so it essentially walks. So the animation that we actually want to set up is of the turkey tilting forward and hopping. The trick, or the difficult bit, is getting the length of the animation that's associated with the torso tilting and creating the hop animation. There might be, it's likely that there'd be a disparity between the number of frames it takes for that to, let's say for the sake of argument, just do that, tilt back and forth, and for this just to move along the ground. And what can happen is that you end up with the two objects desynchronizing. So if you're not careful, the feet will trundle along and the torso will still be sat where it's sat. So that's the disadvantage with using nodes for more complicated objects, but for simple things where you need each object is separate and is controlled by a master node, it works perfectly fine. So what we may need to do is use an armature. So for this, now I have to remember how to do this, funnily enough. So let me just double check the old furniture sample file. Is it that one? I think it's that one. Yeah, it's that one. So this is what we need to replicate. So which way? So that's lying on its back. Right, so that's like it's lying on its back without pointing up. Okay, so what we can do here then Right, so let's see if this works. You're going to see something untried and untested. So let's add an armature. Add armature single bone. And as per usual, it's super tiny. So we need to go into edit mode. Let's just double check that it does go into it. So we're in edit mode and we just need to scale that up. So that's right click the tail node, which is the top, the thin end. Oh, and we're still make sure that the 3D widget is where your selection is. So pivot point, set that to either active element or median, doesn't matter which. So zoom out, and we need to make that relatively large. So we've got one bone. In fact, actually what we want to do with this is we need to make the bone essentially the height of the legs, and then just reposition that so that it's where the legs actually are. Right click the top node, or the tail, the thin end again, press the E key and just extrude a second bone. Hold the control key down so that you snap to the grid, or once you've extruded, you've initiated and created a bone, just left click drag the blue handle of the widget upwards and you can hold down control to snap to the grid. So we've now got two bones. Right click one of them, right click the main body of the bone. We want to call this torso. So in bone properties, call it torso. Let's turn the names on so that we can see them. Oops, wrong one. Axes. So I don't know if that can be seen on the video, but that's called torso. Right click the bottom one, and we want to call that one feet. So what we've got now is a bone chain, a simple bone chain. So it's just two bones. That's all we need for this. Now we have our vertex groups already set up. Let's see if I saved over that. No, that's okay. So double check. Select the feet, deselect, select the torso, select. Yes, turkey bones, turkey leg bones. It's where the brown meat is. So the bones, it's important that they be named the same as the vertex groups, because the bones are going to act as the control for the section of the mesh that has that vertex group assigned to it. So all you need to do is make sure that your vertex group assignments are set up, and that you note the name that's being used for either or. In this case we've just got two, but note the name of the vertex groups and then use those to name your bones. So this bottom one is called feet, this top one is called torso. Because what we can do next is right click the mesh, right click the armature, and then parent. Where's parent gone? There it is, parent. and then we want armature deform. Because we've already got the vertex groups set up, we don't need to do any of the other parent methods or types, because it'll create vertex groups, and in doing that it might create them in a way that breaks the vertex groups that we've already got assigned. So armature deform, and this should mean that we can now control the turkey with the armature. So if you right click the armature as an object and press G, the turkey mesh will move with it, or the mesh will move with it. And then if we go into pose mode, hopefully this works because it's been a while since I've done this. We switch to pose mode, so that's with your armature selected, right click, pose mode, and what we should find, let me just enable X-ray, what we should find is that if we manipulate the torso bone, the upper section of the mesh should move. Well, hey, and it does. And then check your and that's basic rigging. So we've got a rigged object. So what we can do next is so let me think. Okay, so let's just do a very simple animation for this. I was going to do a hop, but that's probably going to take up more time than we've actually got, really. So let's just do a simple tilt, as if it's pecking at the ground. So we want the timeline, but we want to switch this to the dope sheet, and then use the action editor, and that gives us this timeline, which is blank at the moment. So we want to switch into pose mode, make sure we've got both bones selected. So you can either use your shortcut, which is the A key, or select and then deselect all. Want both of them selected, and then what we can do is just press the I key, or from the pose menu, where's insert gone? Animation, insert keyframe, and what you should see, two orange spots and a couple of bone entries corresponding to the bones that we've got selected. So pose, animation, and then we get this selection, and we want lock rot, that's location and rotation. We can't do scaling. And that's the first frame of a simple animation sequence. And we've got two bones, we've got the torso bone and the feet bone. So all we need to do is move the timeline slider, that's this green thing, let's say that at frame 60, and just repeat the same process. So press the I key to insert, lock rot, and that'll create a duplicate of that same pose, and that's indicated by this orange line. So in between, what we can then do is right click and then just tilt the bone, left click to set its position, then press the I key again, lock rot, and that'll set a pose for that bone, so that what we have is the thing bending or pitching forward. And obviously, depending on the setup that you use, you can make this more complicated. So you could have another bone at the bottom of the feet, so that you could tilt this and the feet would stay flat with the ground, but you tilt the entire object forward. But that's a simple animation, just doing that. So it's like that, what's that? That's, what's that water toy that tips forward? That bobs. I think you put it on the edge of a glass or something. But that's a simple animation. So what we then need to do, the water thingy, yeah. I knew you knew what I meant. That water thingamajiggery. Before we export this though, what we want to do is parent this armature to the furniture root node. So right click the armature, then shift right click the node, and control P or object, parent, object, keep transform. And again, double check, right click the node, the furniture node, and what we should have is everything moves with the furniture node. Let's just get rid of these to hide those. H. So if I let this run, how many frames have we got? 60, so if we do Alt A, that's the animation playing through. Right, so save this, save as 18. Now this is the experimental bit, so you are witness to some experiments. This is where it gets, we're not entirely sure whether this is possible, because we're mixing structures together. Normally you would use another bone of an armature as the root bone of the furniture item, which is what this was. Whoops. That's what this is. So this bone that's lying on its back is the root bone of the furniture. So that's root. It's called root. Yeah, it's called root. And then what you would do is you would parent whatever it is. If you wanted animation, say for instance one of these cubes is parented to this bone, so when that moves, the cube moves with it. So the node setup that we've got now replaces this node that's this bone that's lying on its back. So this is where the experimenting comes in. So let's try this. So we want to right click the mesh, shift right click the armature, and then shift right click the root node. Then FBX Export. We can keep file name, that's okay. Selected objects. Disable use modifiers, blah blah blah. Well, this is what we're about to test, Liana, whether we can use a node for position within the room and an armature and bones to control the object. So we're about to test that now, live. So this may not work. Armatures, disable add leaf bones. Make sure that that's always disabled. And then for animations, we want to disable NLA strips and force start and end point. So what we should have left is bake animations, key all bones and all actions. And what this does is it forces the FBX export process to create a single action sequence per animation. So if you had several, so down, let me just move this, flip this to the top. So that was a right click. If you right click any space within a header, which is this strip that always runs along either the bottom or the top of a view, if you right click in any of the empty space, you'll get the pop-up menu that allows you to flip the thing to the top or the bottom of the area that you're in. So if I select the armature, what we've got is armature action. So we can actually rename this. So there's Turkey Bob. Turkey Bob. Want to, you don't need to do this specifically if you've just got, we've only got a single sequence, so we don't necessarily need to do this. But if you had more than one, always make sure that the F fake user is active. So if you have more than one sequence, let me just save this now that I've done that. Save. If you have more than one sequence, when you export FBX, oh hang on, need to select the objects. Right click, export FBX, selected objects, geometry, disable that, armatures, disable that. So what this is doing is creating a separate action sequence for each animation that you might have. So you could have the turkey bobbing, you could have it hopping along, you could have it doing all sorts of other things, and each of those action sequences would be a separate sequence within the FBX file. So let's test to see if this works. So we've got our file name, FBX, settings, yep, that's okay, and then export. So let's see if this works. Create mode, derive new product, furniture, go. So we've now got our default furniture item. So now we import the FBX file. So FBX tab, load FBX, find our FBX Turkey, Robot Turkey 18, open. Now this is the skeleton selection box I was talking about earlier. So it's given us an option, and it'll do this depending on the project that you've got. So if we looking back at the Blender file, we've actually got two separate hierarchies here. One is the armature and the bones it contains, so it's just got two bones. That's a two bone hierarchy. The object has essentially four objects within it, and that's the skeleton that we want to select. So we've got root with 4 bones. Well, it's actually it's 3 bones because the FBX automatically writes a root node into the FBX file, so it thinks that there's 4 bones. So we want that one. It's got our Turkey mesh assigned, that's okay. So configure FBX, and that brings all the usual data in. So we need to change the mesh ID again, 0, and we can double check our skeleton. So we've got root, armature, feet, torso. So this should work. Check our materials, and there is our animation sequence, and that is telling us that is that 73. So that's 73 frames. Did we do it at 73 frames? Don't think so. Let's see what it does. Scale 0.01, and then import. Yeah, so drum roll please. We're replacing the default materials, that's okay. So import changes, and then don't do it, apply change. Let's see what this does. Oh, it's there, excellent. So we need to go into config, make sure that it's assigned to the correct skeleton. So it's kept the, obviously it keeps the derived items original, but we want the one that we imported. So that's okay. Meshes, that's obviously okay because we can see the mesh and all the textures are assigned. So next we want to assign an action. Click the add button. Is it stance? It's stance idle. Stance dot uppercase I DLE. So this is room. Want 0. 0 is infinite. No pun intended. After playing, select the same ensemble. Right, so that's our core properties for the sequence. So this is triggering the object to play the animation as soon as the object loads, or you could type a trigger word. So you could type Turkey Bob in there and it won't activate the animation unless you type Turkey Bob. With the FBX imported, we should have our animation sequence in the skeletal animation, and it's there. So select that, and we want loops, we want that to be 0 as well, for that to be infinite. And then let's leave the others as is. Composition to replace. Apply changes. Oh, and it's worked. Absolutely fantastic. So there we have our bobbing turkey, or Turkey Bob. So let's save this. I'm really chuffed with that. Didn't expect it to work. So let's save that. FBX Turkey Bob. And it'll keep playing because we've got it at stance idle. So if we wanted this to be triggered, let's delete that and then apply changes and it'll stop. So let's type Turkey Bob. Turkey, whoops, Turkey Bob. So we've made a change, so we have to apply it. Now it doesn't do anything, so we need to type Turkey Bob. which you can't see because we're obviously text is all the way up there. So Turkey Bob typed, press enter. Well, hey, it works. So you can imagine a field of turkey robots all bobbing. That's very cool. I'm genuinely surprised that that's worked, because I wasn't sure. But you can see now how you need to have. It's going to be tricky to use nodes to do even simple animations like this. If you just have, so if we just wanted this turkey to just slide around without doing anything, we could use nodes without any problems. But as soon as you want to do something a bit more complicated, like this sort of articulation that we're doing right now, you generally need to have bones. But the advantage of what we just did is that we can use a node as the master or the root node of a furniture item, and we can just use a skeleton any which way we think we can use it. Doesn't matter, so long as the hierarchy is that the mesh is parented to the armature, and then the armature is parented to the root node. That produces on export a functional item. Yeah, so that's excellent. So let's just enable vertex. That's vertex colors enabled there. Let's go down this and make sure that all of these are set. See, it was worth the long wait. It's taken us since Thanksgiving to get this far. So we've enabled vertex colors, and then just enable those, and it shades the mesh, and of course it stops because we've applied the change, and so we need to reset the trigger. Let's just save that over the file that we've got, and that's creating an animated furniture item. So there you go. So if you've got any questions in relation to what we've just been doing, ask away, and we'll see what else we can. Well, we're coming up to 2 hours now, so we'll just do a bit of a Q&A, and then call it quits. And then I note that Jinx and Prim just went live, so we can we'll stop it at some point in a few minutes, and then it'll free everybody up to go and watch Jinx and Prim. Let's just wait for chat to catch up with questions. That's very cool. I was surprised that worked. So, Turkey Bob. So I'm typing the note with the word in. Fantastic. The nodes, these are nodes. The nodes that we created, we don't need to use them for this, and it's just not feasible for this particular type of animation. So Leon is just asking about the other nodes. So let me just unhide those. So that's Alt H, and then just rehide the cube. So the nodes that we created, we can't use those for this particular type of animation because we can't create the proper hierarchy between all the objects and have the objects be controlled as a single unit. In order to use nodes, you have to have separate mesh objects, so that would mean that we would have to detach the torso from the legs, and the torso would then be controlled by its node, and the feet would then be controlled by its node. But because you're doing two separate groups of objects, you've got issues or concerns with synchronization in terms of the animation that you're doing. So it might work with a simple bob where nothing else is moving, but if you want the bob and a hop, let's say, you've then got to try and synchronize the two groups of objects together, and that's why it's going to be tricky to do that kind of animation with a node setup. So it's easiest or easier to just use an armature as your control mechanism. So that's what controls the mesh, but then the root node controls the object overall, and that makes it's easier to do it that way. And that way you can potentially, it might be possible to even import things with multiple armatures. So if you were doing really complex objects, I'm not sure what you would use it for particularly, but using a root node as a control and then parenting your armatures to that, it basically means that you can in theory use multiple armatures to control multiple objects. So that would be another interesting experiment for somebody to try. Hint hint. Yeah, so bones, for doing animations like this, bones tend to make more sense. But for simple sequences, you can just use nodes. So if you were just having those, as was showing earlier with the planes, the surface planes. Whoops, that's the wrong one. If you were doing something like this, you just need individual nodes, and that's fine. That would work fine. It's when you need to do more complicated animations that you need to start considering using an armature, but your setup doesn't necessarily need to be complicated. Yes, Hot Rod, you can use nodes. I mean, you still have to, if you think of the root node, this wireframe basically replaces the bone from the old Cal 3D file that pointed out backwards from the mesh. And what that meant, or what that means now, is that because the root node is separate, it essentially means that it may be possible to group more than one element to the root node. You couldn't do that with the old template because obviously you've only got the one root node, and that root node is associated with the armature itself. So you can't add any other objects to this other than them being parented and controlled by the bones that you've got in this default armature. So if we use a node instead of a bone, we've detached the control mechanism for the entire object. We've detached that, from the thing that we're actually trying to animate, which means that in theory, we can probably collect together more objects under FBX than we could do with Cal3D, which is what this template iteration of the file is. So there's some things to test. So projects with multiple skeletons parented to a single root node to see what the FBX exporter does with that. Not so. Liana's asking. So, if you wanted the turkey to hop, no, not really. Like I say, the armature is what's controlling the mesh. The root node controls, if you like, the project, the entire thing. So, if you want the turkey to hop, you leave the root node alone, don't do anything to that, and you move the so let me just I'll do that quickly actually whilst we are, and then so we need to create a new sequence. So we have the armature selected, so we need to create a new sequence. So plus, that duplicates the one that we were working on and gives it a unique name. So if we just call this turkey hop, we've now got two sequences. So we've got turkey hop and turkey bob. It sounds like somebody's name, turkey bob, turkey hop. So with turkey hop selected, what you would do in pose mode, switch to pose mode. So we've got our sequence marked. And we can in fact still use those. So what we can do is move the frame marker to frame 20 and just move this along the ground. Let's just move it a short distance. Insert the keyframe, location rotation, and that's moved the object, and it'll just, at the moment, it'll just return or reset. So if you were doing a hop animation, you'd obviously then want to add more frames and have each frame marked out where you wanted the turkey to be positioned. And of course you can use your rotate and position widgets. And after you've posed, insert your keyframe, lock rot, and this will look a bit weird, this. And that's what you do. And then when come time to export, you just export in the same way that we just did. And what that will do is it'll pick up on the fact that there are two sequences and export them as separate animation strips. And again, don't forget to enable the F fake user option so that Blender keeps the file, keeps the data in the file. And then once you've got that, just export and bring it into IMVU and set it up as we just did with the single animation. Yes, it is. It's a tween. So you're basically marking out your keyframes. That's Hot Rod asking about tween. So you're marking out your primary keyframes, which is obviously why they're called keyframes. So you mark your keyframes, and then essentially the process does the rest. It tweens, in-betweens the keyframes, and it does it based on time. It's a time sequence as opposed to a positional thing. So that's all you need to do, and it'll export And so we can do that now. Excellent, excellent. Okay, well, I guess we'll call it quits there, so that we can, if you want to go and watch Jinx and Prim, so that's twitch.tv/Jinx and Prim, and then you can go and pester them for a bit and shenanigans, and then we'll see what we can do with this. We might try doing some more complicated animation with this, which will require setting up a more thorough armature for it, but we'll see, because there's also the possibility of turning this into a seat with a custom seat node. All right, until, well, it'll be Tuesday. I guess the next session will maybe Tuesday, but might do something that's not specifically related to Shannon Mack learning how to make love in text in Blender, and I can't believe I have to keep saying that he has to learn how to make love. Oh, the puns. That's on Tuesday. Might do something tomorrow that's not related to that, but we'll see. All right, everybody. Until next time, we'll see you, well, next time.